Hey friends, this is Tom Vaidyan. Today we are starting a new series that I'm calling Automated Testing for the Web Developer. I consider myself primarily an ASP.NET developer, so my main focus will be on that space. So if you are someone writing web applications on a Microsoft stack, whether that be ASP.NET MVC applications on full framework, or .NET Core applications, or recently rebranded .NET 5 applications, you will certainly feel at home here. But if not, I would still encourage you to stick around because some of the concepts that you learn here can still be applied to your own stack and set of technologies. And as the series progresses, we'll also be doing some automated testing in a client-side JavaScript framework, namely Angular. At the onset, I want to give you a high-level structure for the series so that you have an idea of what I plan to cover. Part 1 is this video that you're watching, and in this one, we are going to explore at a very high level what automated testing is all about. Why is it useful? What are some of the tools available for this? What are some of the different types of automated testing? And we'll also explore some of the common terminology associated with automated testing. I will also show you how to set up some of the automated testing tools that we will use in this series, and we will even write a couple of very basic unit tests. In the next session and the sessions that follow, we will look at sample ASP.NET applications, something a bit more substantial than your typical Hello World application, so that we could address some of the real-world concerns that you will have in your software development practices. How do we structure our code? I'll go over some specific architectural ideas that you can use in your applications that will aid in your testing. And in the sessions that follow, we will get our hands dirty writing a slew of unit tests, integration tests, end-to-end tests, hopefully getting you comfortable in these so that you could go back to your development teams and implement these practices in your own development projects. Enough of the introductions. Let's switch over to Visual Studio and write a couple of unit tests. So here we are in Visual Studio 2019, and I have a simple console application loaded in. We are going to start with something very basic and progressively work our way up, so that we could first get a hang of the mechanics before we dive into deeper concepts and approaches. And to that end, I have a couple of simple classes written here that we will write unit tests against. If you've never seen what a unit test looks like, just follow along with me and we will write our very first unit tests. So let's take a look at this first class I have here, that is my greeter class. It has one single method, the sayHello method, and it takes a parameter name. And this method returns a customized string with the name that we passed in. So if we pass in Tom, the method will return hello Tom. Now, does our code do what we think it would do? Let's write a unit test to find out. First, I'm going to add a new project to my Visual Studio solution so that all our unit tests can have its own separate container. So this will be a new .NET Core class library project, and we will name it unit tests. Now this template comes with a class1.cs file. We will rename it to something a bit more useful, such as greeter tests, so that we could use this to house all our unit tests for the greeter class. Now, in this new project that I have created, I'm going to add a reference back to the application that I'm testing, so that these two projects could be linked together for testing purposes. Now let's use the NuGet package manager to download a few libraries that will help us in writing our tests. The first thing that I want to download is a library called xUnit. This is the test framework that we'll be using throughout this series. Next thing that I want to download is the Microsoft.NET.Tests.SDK. This package is what is known as a test host. It is responsible for executing the tests that are in our project using the testing framework that we picked in the step above. And the last package that I want to download here is xUnit.runner.visual studio. This package is the link between our unit testing framework, which is xUnit, and our test host. Alright, now that we have the tools in place, let's write our very first unit test. I will add a using statement at the top to reference the xUnit classes in my code below. Now, our test will take the form of a plain old C# method. We will give it a nice descriptive name that explains clearly what we are testing. Don't worry if the name gets a bit wordy. We want to clearly describe what it is doing. A common naming convention that I like to use is to first start with the thing that we are testing. So in our case, that's say hello. Next is to describe the scenario that we are testing. In our case, we will just call when called with a name. Third is the expected behavior. In our case, we expect the say hello method to return us a customized greeting with the name that we passed in. So we'll say return a greeting with that name. Now we have to mark this method with a special attribute called fact so that xUnit will consider this as an actual test as opposed to a plain old function. Now a common pattern for writing tests is the AAA pattern. This divides your testing code into three parts. Arrange, where you'll set up the thing that you're testing. Next is the act part. That's where you will invoke the method that you want to test. And the last part is assert. This is where you check and see if the code did what you expected it to do. Now first, the arrange section. I'm going to create a variable that will hold the object that I'm testing, and that's the greeter class. So let's new up one of those. And I'm going to press Ctrl and have Visual Studio add a using statement for me to allow me to reference the greeter class. Next, let's move on to the act phase. What do I need to invoke? I want to invoke the say hello method of my greeter class, so I'll do that here. I'll pass it the name Tom, and I will expect the method to return the greeting in this variable here. Now the last part, assert. xUnit, like all major testing frameworks, give you a set of classes and methods to compare your expected result with the actual result that you got from running your code. So I will use one of those here, assert.equal. As you can see here, you can use this method to compare different types of things. I expect that my say hello method will return a string that says hello Tom. And I will pass the actual result that I got as the second parameter. Now, let's run our tests. For that, we will bring up the Test Explorer in Visual Studio to execute our tests. We can see the unit tests that we've written appear in the Test Explorer. If not, build your solution so that the tooling will be able to discover your tests. Now let's run our tests. Congratulations! We've written our first unit test, run it, and it has passed. Our code is doing what we expected it to do. Now I'm going to head over to the greeter class and purposely introduce a bug in my code and rerun the test to see what a failed test looks like. Instead of having it return hello Tom, we are going to return hi Tom instead. Now let's rerun our tests. Our test failed as we expected. Our unit test has caught an issue in our code. Now this is clearly a contrived example, but you can imagine the power and flexibility this gives you. The freedom to make changes in your code and instantly see what the impact of that change is on other existing parts of the software. We'll explore this idea further in sessions to come. But here in the details, you can see clearly what the expected outcome was and what the actual outcome was. Now let's revert the code back and rerun our test once again. I'll change the string back to hello. And rerun the test. Great, we're back to all green. So, one may ask, what's the big deal with automated tests anyway? You're here watching a video on automated testing, so I assume you've answered this question for yourself, at least to some degree. But maybe you need help to vocalize those same concerns to the rest of your team. Here are a few reasons why I think automated testing is a very good integral aspect of software development. And this is by no means an exhaustive list, but I think it covers most of the widely accepted benefits. First of all, manual testing doesn't scale. I've been on teams where we develop a new feature for the application and then commit the code, release it to some testing environment, and then tag a tester to see if it works. Sort of the whole proverbial finish your work and then lob it over the cubicle wall scenario. That may work in the beginning, but it doesn't work in the long run. When your software has a very limited set of features, sure, you can ask someone to test it and give you a green light, but as the complexity of the software grows and you have more and more interlocking pieces, that testing becomes increasingly difficult. Especially regression testing. Your new change may affect a seemingly unrelated aspect of your software, and now the tester has to pretty much test the entire application to make sure that your code didn't break something else. This brings me to point number 2. Automated tests are quicker. Most of the tests, especially unit tests, will run in sub-second time. You can run a 50, 100 unit test easily in a couple of seconds. Even integration tests with databases and data persistence and all, you can still run them in record time, so much faster than any human can. Number 3, reliability. Generally speaking, automated tests are reliable. I qualified that statement by saying generally speaking, because you can write bad tests that are flaky, that will give you an okay one time but fail another time. Or be dependent on network latency or some other variable causing false positives. But putting all that aside, generally speaking, automated tests are reliable. They'll run exactly like you programmed them to. On the other hand, a human tester can forget a step or forget a whole test for that matter. And 4, automated tests as a side effect documents your code base. When you are looking at someone else's code, you can bring up the unit test for a particular class and read those. Good tests will read very well. They will have very descriptive names, and just by glancing through those, you will have a good idea of what that code is doing. 5. Next is the whole idea of compound interest. The test you write today against a small class not only benefits you in testing your small piece of code, but you are adding to a library of tests that you and your team is maintaining from the very beginning. So the next developer that works on the next piece of functionality has the benefit of running that entire library of tests to make sure that their new addition hasn't caused any problems to something else. And that brings me to the final point in my list. Automated testing gives you and your team confidence. We've all been there. We inherit an application that has been maintained for several years. Most of the people that worked on the critical pieces are now long gone. And now you need to make a change to something. We've all felt that sense of fear and trepidation. This software is the lifeblood of our business, and now I'm going to make a change, and I could break everything. People are afraid to touch it. Why? Because of the fear of the unknown. You kinda sorta have an idea what the software is doing, but you don't have any guardrails. Well, automated tests provide you those guardrails. It gives you better confidence with some good level of certainty that the change you put in will not have an adverse impact on the software system as a whole. And if it does, You can find out during development time that something is wrong rather than having bad piece of code, make it into production, and now you have to put a hotfix in as quickly as possible. Having a suite of automated tests for your code base should make your job a bit easier, a little less stressful, and over time, it can build a confident and happy team. So here we are in Visual Studio once again. Let's write a few more unit tests. I have another simple class loaded up here called To-Do List Manager. This class has one property called To-Do List, which is a list of type string. This class also has a method called Add To-Do, which takes in a single parameter, a string, which is the to-do item that we want to add to the list. Does this code work? Let's write a unit test to find out. I'll first create a new file named To-Do List Manager Tests. We will add a using statement for xUnit at the very top. Now we will write a public void method. Remember the naming convention I used previously? The first part is the thing that you're testing. So that will be our add to do method. Next part is our scenario. So we will enter when called with the to do item. And the last part is the expected behavior. So we will enter adds item to list. Now remember the AAA pattern? First part is arrange. We'll set up the thing we are testing, which is our To-Do List Manager class. Let's new up one of those. Now another common convention that you will come across is the naming of this variable, the class that you're testing. In unit tests, you will commonly see developers naming this variable as SUT. SUT stands for System Under Test. I'll use that same naming convention here. Next is the act part. We will call the add to do method here. We'll pass it a new to do item of get milk. Third is the assert part. What do we want to assert? We expect our new item to be added to the to-do list after the action above. In our To-Do List Manager class, we have the to-do list property set up as a public property. So we can check the length of that list and confirm that it has one item, the get milk to-do item that we added above. One way to check that is to use the assert.single method that xUnit provides. This method checks to see that the I enumerable that we are passing it, in our case the to-do list, has a single item within it. This helper method will also return that single item, and we will store that in our result variable here for our later use. Lastly, we will decorate our method with the fact attribute to denote that this is a test so that it will be picked up by our test host. Let's build our code and check the test explorer. And here's our new test. Will it pass? Let's run it and see. Our test has failed. Let's inspect what the problem is. There is clearly a bug in our code, and I'm sure many of you already spotted it while I was showing you the code earlier. The details here show that we have come across a null reference exception. If we go back and look at our To-Do List Manager class, we'll see that our to-do list never gets initialized, and here on line 11, we are trying to add to that uninitialized list. That will certainly cause the null reference exception that we saw when we executed our test. But what I'm demonstrating here with this contrived example is that our compiler never stopped us, and if it wasn't for our unit test, we could have easily pushed this bug into production. Let's fix the problem by adding a constructor and initializing our list. Let's rerun the test. and this time the test passes. Next, let's add another assert to our unit test here. In addition to checking that the list now contains one item, let's inspect that single item and confirm that it is indeed the getMilk task that we passed in. Let's rerun and see if it passes. Yes, it does. So we were able to add a couple of assertions in a single test. xUnit will allow you to add as many as you want, but we should try to minimize the number of assertions that we do in a single test. A lot of assertions usually is a code smell. Perhaps you need to consider breaking it up into multiple tests. Maybe the application code itself is doing too much, and that needs to be refactored. Another positive side effect of writing unit tests is that it generally gets you to write better code overall. Okay, let's move on to another example. Here I have a calculator class. My class has one method, get the sum of two numbers. It takes two parameters, two integers. The method simply adds them together and returns the sum. Let's write a few unit tests against this method. I will add a new file called calculator tests. I will add a using statement for xUnit. We will create a public void method. The thing that we are testing is the get the sum of two numbers method. The scenario that we are testing is that we are calling the method with two numbers, and we expect the method to return us the sum of those two numbers. Let's new up a calculator object. Let's invoke its get the sum of two numbers method, and we will try to add the numbers 1 and 2. Let's assert that we expect the method to return a 3. Let's build our code and run this. And yes, it passes. Now, what if we try to add two negative numbers? Will our code work? Let's test it and find out. So I'm going to copy this unit test here and paste it and rename it to test our second set of test data. Now let's build and run. Yes, this scenario passes as well. How about when we add 0 to a number? Will our code work then? Well, let's write another test. I will once again copy and paste one of our existing tests and rename it. Let's change the parameters. Let's build and run. And yes, this passes too. But obviously, you see a problem here. I'm duplicating a lot of code here. The only part that is actually changing is my test data, not the tests themselves. What is a better approach to do this? Well, xUnit provides another way of doing these parameterized tests without duplication of code. And that is through the use of the theory attribute. I'm going to delete all but one of these and then change the fact attribute to a theory attribute. With the theory, we will pass parameters into the test. In our case, the two numbers that we want to add and the expected result. We will remove these hard-coded test values and instead use the parameters that we have set up. Now, how do we call this test with different test values? So for that, we will use the inline data attribute. So we will create one with values 1 and 2, and we expect a return value of 3. Next, we will add another set of test inputs. This time -1 and -2, and we expect a return of -3. And we will add a third set to our test, and that is adding a 0 to a number, and that will yield us the original number. Now let's build and head over to the Test Explorer. We can see our 3 sets of test data appear as 3 separate unit tests here. Let's go ahead and run these. So with the xUnit theory attribute, we are able to run our unit tests with different set of test data. We will explore more features of xUnit in following episodes. So far, we've been looking at unit tests. What are some other types of automated tests? You have probably seen this diagram in your research. It's known as the test pyramid, and there are a few different variations of it. But fundamentally, there are 3 types that we deal with in terms of automated testing. At the top of the pyramid, we have E2E, or end-to-end testing. In the context of web development, this usually means some sort of browser automation. An automated system that programmatically opens a browser, goes to a specified URL, inputs some values, or interacts with the DOM in some way, perhaps clicking a link or pressing a button, and then inspecting the change in the DOM. Does the change reflect the expected outcome? This is probably the type of test that we can generally wrap our heads around, right? Because it is simulating what a human tester would do. How do we test our web apps? We open a browser, we click on things, we enter values into form fields, presses buttons, and expects certain things to happen. End-to-end tests do that. But as it is at the top of this pyramid, we should devote, relatively speaking, less time into writing these in comparison to integration tests or unit tests. Why? Because generally speaking, they are slower to execute, they're expensive, and they're brutal. What do I mean? Since this is targeting your application like an end user, we have to consider your application as a whole. You have to figure out how to reset your database after each test. We have to redirect API calls that you may have to external systems, sending out of emails. So generally speaking, you want to write a few of these. Maybe test out a couple of your most critical user stories. Next is integration testing. This is where you take a few of the elements of your application and test them together. You will generally not have a browser. Instead, you have some code that makes a call to your API and gets an HTTP response back, and we test to see if it matches our expected results. You still have some complexities to deal with, like how to reset your database. But since you are only dealing with few pieces of your application at a time, you can construct some meaningful tests and maintain it over the lifetime of your application. Some people consider integration tests as the best tests to have because they mostly align with how an end user will use your software, and thus be a pretty good representation of the state of your software. Now moving on to the base of the pyramid, unit tests. These are the cheapest tests to write, meaning they run the fastest. You can have a lot of them. They don't take a whole lot of effort once you get into the swing of things, and it doesn't get in the way of your development too much that you could run it often during the development cycle and get constant feedback of whether you're breaking things or you're generally going in the right direction. Believe it or not, it is not without controversy. People argue what the definition of a unit is. Is it a method? Is it a class? Is it a module? Can you write your test against an in-memory database and still consider it a unit test? As pragmatic developers, we're not going to get hung up on those things. For the purposes of this course, a unit test is generally scoped to a single method in a class. The important thing is that we learn how to use this tool, one of the many tools in our toolkit, to produce better software applications. I wanted to call out some of the popular libraries that are available to aid us in our automated testing, and along with it some terminology that you will come across in the domain of automated testing. They fall into different subcategories. First classification is testing libraries. These are essentially the frameworks that we operate in when we write our tests. In this video, I used xUnit, but NUnit and Microsoft's own MS Test framework are worthy alternatives as well. Next category is substitution frameworks. When we want to write a test, especially a unit test, we want to focus in on a particular method in a particular class. But those methods and classes don't normally operate in a vacuum, but will have hooks into other classes and methods as well. We will use a substitution library to deal with all those other related pieces. Have it substitute or fill in for those pieces so that the piece of code that you're actually interested in testing can be executed properly. In the .NET world, that's mock or MOQ, and that's the particular library that I'll be using in this course. Other alternatives in this space are nsubstitute and fake it easy, just to name a couple. Next category is assertion helpers. We want our test to be readable like our natural language. Earlier, I mentioned that our tests are in some way living, breathing documentation of our code. A developer should be able to look at the test that we've written for a class and get a very good understanding of what our class is doing. Assertion helpers assist in this regard. They make tests very readable. Fluent assertions and shouldly are a couple of libraries that do just that. Moving on, next category in our toolkit is called test runners. As the name implies, this is the thing that will actually identify our tests and run them for us, give us visual feedback on how many tests it ran, what was the outcome of each, etc. We use the built-in test runner that comes with Visual Studio. Also, there's a built-in test execution method that comes with .NET, and I mean .NET Core or .NET 5, and that's .NET Test. We can execute that from the command line, and .NET would find and execute our test for us. We'll use that too in the future. Coverlet. This is a good open source tool that helps us in reporting code coverage. What percentage of our code base is being covered by one or more tests? What's not covered, etc. A couple of other things on my list that are not categories but other tools that we will use. One of them is xUnit's iClass fixture. This interface allows us to set up some state that we can reuse for all our tests in a test class. We will use that in our integration tests. Next is another class that comes with .NET, Web Application Factory. This allows us to basically new up our .NET app in memory so that we could use it in a test, namely an integration test, without needing an actual web server to run our application. That's it for now for .NET. There are similar constructs for Angular and other JavaScript frameworks too. Jasmine, Karma, Protractor, Cypress, just to name a few. We will look at those in later episodes. Hey friends, my name is Tom Vaidyan and I'm a software engineer with a focus on web technologies. And I've been working in this space for the past 20 plus years. Thanks for watching this opening video of my automated testing series. I hope you found this useful. If you have questions, please do leave a comment for me and I'll try to get those answered for you as soon as I can. If you want me to cover specific things in future videos, please let me know via the comment section as well. If you haven't already done so, please do hit that subscribe button and click that bell notification icon so that you could be notified of future videos. If this session helped you in the least, please do click on that like button so that others can discover this video as well. If you didn't like it, please still hit that like button and leave a comment for me on how I can improve my future videos. Until next time, happy coding. Thank you.